So from each plant, these 4 types of gametes are produced as they are formed by law of independent assortment. So in the in F1 generation, when this type of mixed plants are produced, they will interbreed because the plants of the previous generation are dead, and from each one 4 types of gametes are produced, and from the another mixed type of pea plant these 4 types of gametes are produced. And as it was seen that the male and female pea plants were symbolized like this, and from each pea plant 4 types of gametes are produced. These gametes will get combined by sexual reproduction to produce these 16 individuals, and taking the row and column, we are producing the individuals respectively. Like when these 2 gametes are produced, they are getting fused together, that will produce this one. These 2 will produce this one, these 2 will produce this, and these 2 will produce this. Likewise, we will proceed in other cases also. But if the writing of the gametes are sequential and correct in both row and column, then the arrangement of the 16 individuals will be correct also. And after writing these individuals, we have to count down the similar type of individuals. So we will apply a numbering method which is not written in the book, but it is very much helpful to derive the genotype and phenotype ratio. As these gametes are written correctly, that these gametes can be termed as 1, 2, 3, 4, as well as these are counted as 1, 2, 3, 4. But in case of individuals also, we can write 1, 2, 3, 4 as the gametes are written sequentially. In the column also we can write down 1, 2, 3, 4. And incidentally, we will see that in this diagonal there is repetition of the individuals. As we see, number 2 is repeated in this way. Number 3 is repeated in this diagonal, though on either side of this one. This is quite different from these 2. So these 2 are written 3 and these are repeated. If we see this diagonal, that is 4, all these are 4. So the number 4 is repeated along this diagonal. If we see in between these 2, the left out individual is 5. These 2 are 6 along this diagonal, except this one, because this one is quite different from these 2. So the left out is 7 in between these 2, 6, and along this diagonal these 2 are similar, that is written 8, and the rest is 9. So we can use the numericals to count down the individuals. I repeat, if the individuals are numbered sequentially, that can be written as 1, 2, 3, 4. Along the column also 1, 2, 3, 4. So it is evident that this number 2 is repeated along this diagonal. We will observe that along this diagonal the number 3 is repeated. Along this diagonal all the individuals are similar, so all these individuals are 4 numerically. In between these 2, the left out is 5, these 2 are 6 along this diagonal, and the left out in between these 2 is 7. Along this diagonal these 2 are similar, they are written as 8, and the left out is 9. So it is very much easy after writing these one, the genotype sequentially. We can write this by our knowledge, but it is very much difficult for the students of class 10 to write by knowledge or understanding the genotypes coming one after another sequentially. So it is very much easy by seeing the numbers. We can write down the genotypes of the individuals one after another. One is coming first, then 2, then 3, then 4, then 5, and so on. Right now the what left out is that we have to count down the number which is written, the number present on the board. If we see one is present, one is single in number 1, so capital Y, capital Y, capital R can be written as 1. If we see this one is 2, number 2 is present in 2, so this individual is 2 in number. The 3, we cannot write 3 by mistake. We have to count down these 3. So these 3 are 2 in number. So we have to write down 2. The 4 along this diagonal is 4 if we count it. So the number will be 4. It is not that as we are writing 4, that's why it is written 4. We have to count down the individuals along this diagonal. So that will be 4. 5. As it is 5, we cannot write down 5. We have to count down the individual, how many are there on this board. So the number 5 is single or solitary. So we have to write it 1. If we consider 6, we will see that there are 2 individuals on this board. So we have to write down 2. If we consider 7, it is solitary, and we have to write down 1. If we count down 2 and down 8, the number is present twice on the board. So we have to write down 2. And the number 9 is solitary, we have to write down 1. So it is evident that the ratio of considering the genotype of the individuals will be 1 is to 2 is to 2 is to 4 is to 1 is to 2 is to 2 is 1 is to 2 is to 1. So if it comes in objective, we have to commemorate the ratio. So we can commemorate by using our own techniques. As we commemorate the mobile numbers, the large number, bearing large digits, maximum digits, but we can commemorate the ratio by binomials 1 to 12, 24, 12, 12, 1. 12, I repeat, 12, 24, 12, 12, 1 is the genotypic ratio. And as we see, these 4 initial individuals are similar in character. Why? If we consider the phenotype. If at least one capital Y is present, that represents the yellow cotyledon. If at least one capital R is present, that represents round seed. So all these 4 are yellow cotyledon and round seed bearing pea plants. So we have to count. We have to add these 4. That makes 9. So the number of yellow cotyledon and pure round seed bearing pea plant will be 9. Similarly, if we consider yellow cotyledon and wrinkled seed bearing pea plant, that will be 3 if we add these 2, because at least one capital Y and at least one smaller present in these 2. Similarly, in the next 2 cases, at least one small y and one capital R present. That makes the green and ring and round seed pea plant, that makes 3, and lastly yellow, green and wrinkle seeded cotyledon bearing pea plant, that is 1. In this way the phenotypic ratio is 9:3:3:1. So we conclude the dihybrid crosshair. In the next class we will proceed with other items.